Hello students, today we will learn that what is binary number system used in computers. Okay, so in this lecture we are going to learn that why we use this binary number system, what is the philosophy behind it. We will learn that how to convert the decimal numbers into binary numbers, and we will learn about both types, means whole decimal numbers as well as fractional decimal numbers, how to convert them into binary numbers. We will take some numerical examples, as well as we will learn that how to convert the binary numbers into decimal numbers, and again whole and fractional binary numbers, how to convert them into decimal numbers, and we will take some examples of those also. Okay, so coming to the topic, that you know that in an English alphabet there are 26 letters A to Z, and imagine that there is no alphabet of English and you don't know what English is, and you are given the task to develop an alphabet of letters. Now the question is, would you develop the same English alphabet with same numbers of letter as it is today? The answer is no. It is up to your imagination, your creativity, that what type of letters you want to keep in your alphabet and what they will sound. And you would have observed that for different languages there are different alphabets. Okay, and in all alphabets there are different kinds of letter and their sound is also different. And once an alphabet of language is developed, it is kept as standard alphabet system. Okay, now imagine that you are an early man. You can imagine this thing, and you are in a learning phase of how to count the things. You don't have any idea of any number system, means you don't know what is one, two, three, like this. Okay, so again the question arises that should you develop the same number system with same kind of numerals? The answer is again no. It is up to your imagination and genius level and creativity, that what kind of numerals you want to keep in your number system and how you want to count the things. Okay, we know numerals 0 to 9. It is called as decimal system because from our early childhood it is the only number system taught to us. So we believe that the things can be counted only by the help of these numerals. Okay, so in decimal number system, what is there? There are 0 to 9, 10 unique numerals, and rest of the numbers are made up of by the help of these 10 unique numerals only. For example, 10 we are using 1 and 0, for 11 1 1, for 16 1 6, like this. Okay, now you have imagined some number system. Suppose that is for 0 you want to keep this symbol, that is a rhombus. For 1 it is an oval shaped symbol. For 2, triangle. For 3, four corner star. For 4, five corner star. And for 5 you want to keep the symbol by the help of these five symbols, means as like that of in 10 1 0. For 5 you want to keep oval and this 0, like this is the symbol of number 5. Then 6, it is again oval, same like that of in 11. Then 7 8 9, and then for 10 again by the help of these five numerals themselves. Okay, and similarly 11 this symbol, 12 this symbol, like this. Okay, so again it is up to your imagination what kind of numerals you want to keep, how many unique numerals you want to keep, and what symbols of rest of the numbers you want to keep, and what is the counting system. Okay, so imagine with elapse of era, means you have developed this number system, and with elapse of era decimal number system is also invented. Okay, now by proper mathematical method you can develop a converter also, means if you want to convert one number system into another number system, your number system is this and you want to convert it into decimal numbers, then you can develop that formula also, by the help of which you can change your number system into decimal number system as well as decimal number system into your number system. Okay, so over here, my goal is just to make your mind free that the things can only be counted by the numbers formed by 0 to 9. That is decimal number system. Since decimal number system is only taught from our early childhood, again I am telling this thing. So our mind is used to accept that only to count the things. Okay. Now, physically, computer is a device which works on combination of electrical or electronic switches. Okay, where a switch has two states, on and off. Switch, the same type of switch as we use for our turning the fan on or off. Similarly for our bulb there is a switch, there are two states, on and off. So actually computer is a device, computer is a machine, we can say, which is composed of many switches, combination of switches. Okay, and the switches are very tiny in size. Okay, and there can be logical combination of million and billions of switches in a computer so that it can perform properly. Okay. Now, since there are only two states of switch, on and off, so if we assume 0 to be off, okay, 0 associated with the off of switch and 1 associated with the on of switch, okay, then no more numeral is required to define the state of switch, okay. Thus, the number system which is composed of only two digits, 0 and 1, is called as binary number system, and this number system is particularly used for computers because the processing of computers can be executed by the help of only these two numbers. So binary number is composed of combination of only two digits, 0 and 1, unlike that of decimal system which is composed of 10 digits, 0 to 9. And binary number system can be understood by computers, okay. So this number system is particularly for computers. This number system is not used by human beings to count the things, okay. The logical operation of computer follow the arithmetic and algebra of binary number system. Now, this here some conversion table is there. For example, this is number 0. The equivalent binary number is 0 itself. For one decimal number, again the binary number is 1. For 2, now it is composed of only these two numerals, 1 0. This is the symbol of 2. 3, binary number is 1 1. 4, binary number is 1 0 0. 5, binary number is 1 0 1, like this, okay. So all the decimal numbers can be represented by the help of only 0 and 1. So in the computer, how it performs the calculation, suppose you want to add 5 and 6. So 5 is decimal number, 6 is decimal number. So first of all, computer will convert these decimal numbers into binary numbers. So for 5, binary number is 101. So 101. For 6, binary number is 110. Okay. So suppose 1 is for on state of switch and 0 for off state. So this green color represents on state of the switch and red off. So on, off, on, like this. So like this, the symbol will go inside the processor of computer. Similarly here, this green, red, 110. So 1 on, and 0 for off. So it will go inside, and ultimately it will give the output in form of that on off only, on off of switches. So this green on, off, on. So 1011 is the equivalent binary number after addition of these two binary numbers, okay. So 1011 stands for 11, okay. So equivalent decimal number is 11, okay. Equivalent decimal number, like this. So ultimately it will give the output in decimal form, but initially the output was in binary form and then it was converted, and 5 plus 6 we know it is 11, but the processor of computer calculates by the help of binary numbers only, okay. Now how to convert a decimal number into binary number? Okay, it is very simple. Suppose the decimal number is abcd, okay. Abcd, some number is there. Now what you have to do, divide this decimal number by 2. So when you will divide it, you will get some quotient. When division operation is carried out, some quotient is there. So put the quotient below it, below this number, and you will get some remainder also by division operation. So put the remainder toward right hand side, okay. Now this is the quotient. Now take this quotient and divide this by 2. Again you will get a new quotient, suppose that is hij. So put that quotient below this quotient, and the remainder to the right hand side of this. Again taking this quotient and divide it by 2, you will get a new quotient. Again put it below it, okay, below this hij. Suppose that is ghi, and whatever remainder is there, put the at right hand side, like this. So you have to carry on this operation, keep on doing this operation up to the time you are getting the quotient less than 2. Remember, it can be either 0 or 1. The quotient will keep on reducing. Ultimately, either you will get 0 or 1. Okay. Now you have to write the number as I have shown by the help of this red arrow along the direction. So I am taking an example. Suppose you want to convert this 89 decimal number into binary form. So divide it by 2. You will get quotient as 44 and remainder as 1. Write it at the right hand side and quotient here. Now 44 divided by 2, you will get 22, and the remainder will be 0. Write it at the right hand side of 22. Now 22 divided by 2, you will get 11, and the remainder will be 0. Then 11 divided by 2, you will get 5 as quotient, and remainder will be 1. Now 5 divided by 2, you will get 2 as quotient, and remainder will be again 1, and 2 divided by 2, the quotient will be 1 and the remainder will be 0. Now you have achieved that goal, means ultimately the quotient is less than 2, that is 1. Now as according to this arrow, as it is showing, you have to write the number in that order. So the relevant binary number will be 1 0 1 1 0 0 1. So 1 0 1 1 0 0 1. So this is the decimal representation of 89. 89 base 10 means you have to write, keep the bracket and put a subscript 10 is equals to 1 0 1 1 0 0 1, and 2, this 2 represents that it is a binary number. This is also called as radix of this number. This 10 is the radix of the decimal number and 2 is the radix of this binary number. One more example, suppose the number is 512. Divide by 2. Quotient is 256, remainder 0. Keep it at right hand side. Now 256 divided by 2. 128 will be the quotient, 0 will be the remainder. Okay. Like this, divided 128 by 2. 64 will be the quotient, 0 will be the remainder. Keep on dividing, and ultimately when you will get a number less than 2 as quotient, that is either 1 or 0. So stop there. Now in the direction of this arrow, in that order write the number. So 1 0 0 0 0 0, I 1 2 3 4 5 6 7 8 9 9 0. Okay, so 512 base 10 is equal to 1 9 times 0 2, like this. We have learned that how to convert a decimal number into binary number. Now we will learn that how to convert the decimal numbers into binary numbers, and the decimal numbers are fractional numbers. Okay, means with point. Okay, for example, some decimal number is 89.76 base 10 radix 10 is equals to x base 2. We want to convert this 89.76 into binary number. Okay, so first of all, toward the left hand side, whatever the number is, that is 89, convert that into binary number as I have told you the rule. Okay, so for 89 the binary number is 1 0 1 1 0 0 1. So that is over here. Now toward the right hand side of this point, okay, take that number, that is 0.76. 89 plus 0.76 is 89.76. So take that 0.76, multiply with 2, you will get 1.52. Now this 1, the number toward the left hand side of this point, will be used for binary number representation. Now take this 0.52, multiply with 2, you will get 1.04. Now this one will again be used for binary number representation. Now 0.04 into 2, you will get 0.08. So the number which is left hand side of this point, it is 0. This will be used for binary number representation. Okay, so you have to keep on doing this thing, means you can further do this 0.08 into 2, you will get 0.16. Okay, so you have to repeat this till you get 0 at right hand side, 0.00 infinite times 0. Okay, however you can stop anywhere in case you want limited digits in your fractional binary number. For example, you want to keep only 3 digits after point in binary number, then you can stop anywhere. Okay, now the corresponding binary number will be for 89, it is 1 0 1 1 0 0 1, that I have written 0.110. That's it. So this will be our relevant binary number of 89.76. One more example, suppose the decimal number is 101.86. Okay, so for 101 the binary number is 1100101. By this rule, okay, now take this 0.86. So 0.86 multiplied with 2, you will get 1.72. So 1 will be used for binary number representation. Now this 0.72 multiplied with 2, you will get 1.44. Now this 1 will be used for binary number representation. Now 0.44 into 2, you will get 0.88. So this 0 will be used for binary number representation. So I am stopping here because I want to keep only 3 digits after point in binary number. So the relevant binary number will be, x will be for 101, it is 1100101, written 0.11 and 0. So this will be the relevant binary number for this 101.86 decimal number. Now conversion of binary number into decimal, that can be done like this. Suppose the number is 1 0 1 1 0 0 1. This is the binary number. So how many digits are there in this? 1 2 3 4 5 6 7 digits are there. Now what you have to do? Take the leftmost digit, that is 1, multiply with 2, and 2 raised to power whatever the place number of this one, that is 7th place. Counting from this one toward left hand side, this is the 7th place. So whatever the place number is there, 2 to the power that place number minus 1. So this one is at 7th place. So 1 into 2 raised to power 7 minus 1, that is equal to 6. Now plus 0, zero's place is 6. Okay, so 0 into 2 to the power 6 minus 1, that is equal to 5. Plus 1, this one has place 5. So 1 into 2 to the power 5 minus 1, that is equal to 4. Then this 1 into 2 to the power 3, plus 0 into 2 to the power 2, then 0 into 2 to the power 1, and at last 1 into 2 to the power 0. Okay, Now 2 to the power 6 is how much? 64. 0 into this will be 0. 2 to the power 4 is 16. 2 to the power 3 is 8. This is 0, this is 0, and this is 1. So in case you are adding all these numbers, you will get 89. So the corresponding decimal representation of this binary number is 89 base 10. Now one more example, suppose the number is 11101. This is the binary number, you want to convert it to decimal number. So this leftmost one has place number 5. So 1 into 2 to the power 5 minus 1, that is equal to 4, plus 1 into 2 to the power, this one has place 4, 4 minus 1, that is equal to 3, plus 1 into 2 to the power 2, plus 0 into 2, plus 1 into 2 to the power 0. So 2 to the power 4 is 16, 2 to the power 3 is 8, 2 to the power 2 is 4, and this is 0, this is 1. So adding up all these, you will get 29. So 11101 binary equals to 29 decimal. Now in case the binary number is fractional, then what to do? For example, this 1011.110. So what you have to do? This is the point. Toward left hand side, the number is 1011. So count the place number of this leftmost digit from this point. So that is fourth number. So 1 into 2 to the 2 to the whatever the place number of this one minus 1. So 2 to the power 4 minus 1, that equals to 3, plus 0. The place number of 0 is 3. So 0 into 2 to the power 3 minus 1, that equals to 2, plus 1 into 2 to the power 1, plus 1 into 2 to the power 0, like this. Now after this point, there is 1. Okay. So you have to do this plus 1 into 2 to the power minus 1. 0 is over here. Now you will go with minus 1. So 1 into 2 to the minus 1 plus 1 into 2 to the minus 2 plus 0 into 2 to the minus 3. Okay. Now 2 to the 3 is 8. 0 into 2 to the 2 is 0. This is 2. And this is 1. Now 2 to the minus 1 is how much? That is 0.5. And 2 to the minus 2 is how much? 0.25. And 2 to the minus 3, but it is multiplied by 0, so that is 0. So adding up all these, you will get the decimal number 11.75. Now one more example, that is 10111.1010. This is binary number, you have to convert it into decimal number. So take this point and go toward the leftmost digit, that is 1. The place number of this one counted from this point is 5. So 1 into 2 to the power 5 minus 1, that is equals to 4, plus 0. The place number of this 0 is 4. So 0 into 2 to the power 4 minus 1, that is equals to 3, plus 1 into 2 to the power 2, plus 1 into 2 to the power 1, plus 1 into 2 to the power 0. Now after this point, this one, for this you will use negative powers. So 1 into 2 to the power minus 1, plus 0 into 2 to the power minus 2, plus 1 into 2 to the power minus 3, plus 0 into 2 to the power minus 4. Now 2 to the power 4 is 16, and this will be 0, this will be 4, this will be 2, this will be 1, and this will be 0.5, this will be 0, this will be 0.125. 2 to the minus 3 is 0.125, and again 0. Now adding up all these, you will get 16 plus 4 plus 2 plus 1, and all these numbers you will get 23.625. So this will be the corresponding decimal number of this binary number. So hope by this small lecture you would have understood that what is the binary number system, the philosophy behind that, as well as you would have learned that how to convert the decimal numbers into binary numbers as well as binary numbers into decimal numbers. Thank you.